Consider an electron confined by electric forces to move between two rigid walls separated by 1 into 10 to the power minus 9 meter, which is about 5 atomic diameters. The quantized energy value for the lowest stationary state is, see, there are two rigid walls now, okay, two rigid walls, and an electron moves between these rigid walls and reflects back. So it gives you one stationary wave. One stationary wave is formed by the movement of the electrons. One stationary wave is formed by the movement of the electrons here. Now, for such a case, lambda will be equal to 2L. Lambda will be equal to 2L, and those rigid walls are separated by 1 nanometer. So it is 2 into 10 to the power minus 9 meter is lambda. Now we have to calculate the quantized energy value. So lambda is h by root of 2me, energy of these electrons forming the stationary wave pattern. So lambda is 2 into 10 to the power minus 9 into is equal to 6.62 into 10 to the power minus 34 root of 2 into 9.1 into 10 to the power minus 31 into energy, which we have to calculate. Now squaring this, squaring on both the sides and calculating this is equal to, you are going to get h square by 2m lambda square. So directly right away you can go for this, then you can substitute 6.62 into 10 to the power minus 34 square divided by 2 into 9.1 into 10 to the power minus 31 into lambda is 2 into 10 to the power minus 19 whole square. So using all these things, energy you are going to get is 6 into 10 to the power minus 20 joules. Hence option B is the right answer.